MS Ramaya University of Applied Sciences.
Hi students, let us discuss on determination of chemical oxygen demand, that is COD. Now a question might be arising in your mind, why we should know COD. With the help of COD, degree of pollution in water bodies and their self-purification capacity can be determined. COD indicates pollution loads and efficiency of treatment plants. It provides a rough idea of biochemical oxygen demand, that is BOD. Before performing the experiment, let us see what is COD. COD or chemical oxygen demand is the amount of oxygen required for chemical oxidation of organic and inorganic matter in 1 liter of wastewater using a strong chemical oxidant such as acidified potassium dichromate under reflux conditions. Here, in presence of sulfuric acid, silver sulfate and mercury sulfate, organic and inorganic matter which are present in the sample get oxidized completely by the strong oxidizing agent, that is potassium dichromate. It is necessary to understand that part of the potassium dichromate is used to oxidize the organic and inorganic matter, and the remaining is back titrated against standard ferrous ammonium sulfate solution using ferroin indicator. Dichromate consumed by the sample is equivalent to the amount of oxygen required to oxidize the organic and inorganic matter. Procedure. To start the experiment, first we will prepare standard FAS solution. For this, weigh accurately about 4 gram of ferrous ammonium sulfate and transfer it into a 250 ml volumetric flask. Then, add 1 test tube full of dilute sulfuric acid to avoid the hydrolysis of FAS and swirl the flask to dissolve the crystals. Make up the solution to the mark with ion exchange water, mix the solution well and calculate the normality of ferrous ammonium sulfate solution. Fill the burette with prepared standard FAS solution. After this, pipette out 25 ml of the wastewater sample and transfer it into a 250 ml conical flask. With the help of pipette, add 25 ml of standard potassium dichromate and 5 ml mercuric sulfate, followed by 1 test tube full of 1:1 sulfuric acid containing silver sulfate into the conical flask with constant shaking. Also add boiling chips to the conical flask. Then attach a reflux condenser and reflux the mixture for half an hour and cool. Wash the condenser with ion exchange water and transfer the washings to the flask. Add 2 to 3 drops of ferroin indicator into the conical flask and titrate it against the standard ferrous ammonium sulfate solution until the solution turns from bluish green to reddish brown. Under similar experimental conditions, perform the titration without wastewater sample. Wastewater plus sulfuric acid. Wastewater plus sulfuric acid plus potassium dichromate solution plus ferroin. Wastewater plus sulfuric acid plus potassium dichromate solution plus ferroin plus FAS at the end point.
Hi students, so today's experiment will be to determine the chemical oxygen demand of the given wastewater sample. So here chemical oxygen demand means, so we can say it as COD, shortly called as COD. It is the amount of oxygen required to oxidize organic and inorganic impurities present inside the wastewater sample using a strong oxidizing agent like potassium dichromate. So it is an oxygen equivalent. What it is called as oxygen equivalent. We are measuring the oxygen and finding out how much of impurities are present inside the wastewater. It may be an organic impurities or inorganic impurities. One condition is that it should be oxidized by the oxidizing agent. So like small chain aliphatic hydrocarbons will be not oxidized. So to activate it, we are using some catalyst and also some reagents to control the chlorine interference. So all this we are going to see how we are going to carry out the experiments. We are going to see it today. The glasswares and chemicals required to carry out the COD. So starting with indicator, ferroin. So indicator we are going to use is ferroin. So this is 110 phenanthroline complex of iron with Fe+2 wastewater sample for which you are going to determine COD. So wastewater to which you are going to find out the chemical oxygen demand, potassium dichromate, an oxidizing agent, potassium dichromate which you are using to oxidize the impurities present inside the wastewater, and you are going to calculate how much of potassium dichromate is remaining. So you have to use excess of potassium dichromate when you are taking it to the wastewater sample. The combination of silver sulfate, mercury sulfate and sulfuric acid. So here we are going to use sulfuric acid along with silver sulfate and mercury sulfate. Sulfuric acid to maintain to give the acidic media to oxidize the impurities. Silver sulfate to act as a catalyst. Mercury sulfate to avoid the interference of chlorine. So these are the combination reagents. We have kept it in one reagent bottle, so we can add it directly. FAS solution, ferrous ammonium sulfate. I have just transferred it. A known quantity has been transferred. FAS, or it is generally known as ferrous ammonium sulfate. So this is a reducing agent where using this you are going to find out, means you are going to prepare a standard solution of FAS. So using this you are going to find out how much of potassium dichromate has been remaining. So we can find out indirectly how much of potassium dichromate has been consumed to oxidize the impurities present inside the wastewater. Standard flask, 250 ml standard flask to prepare the standard FAS solution. Conical flask where you are taking the wastewater sample. So you have to carry out the reaction here in the conical flask. Pipette, 25 ml pipette man to measure the known quantity of wastewater sample to the conical flask. Funnel which is used to transfer the liquid or a solid sample to the conical flask or towards the burette. Test tubes, so test tube used to add sulfuric acid and the combination of mercury sulfate and silver sulfate. And so we are using two burettes, one for the standard FAS solution, another for the potassium dichromate which you are going to add to oxidize the impurities. So a known quantity you have to add, so we are using the burette. Wash bottle containing distilled water to wash the apparatus. So let us start the experiment now. So as I say, before starting the experiment you have to see your all glass apparatus should be washed with tap water and then rinsed with the distilled water. So I will show you how to wash it. So one we can see, wash with the tap water, thoroughly with the tap water. Tap water washed, rinsed with the distilled water. So rinsed with the distilled water 2 to 3 times. Similarly, the washing of this pipette, conical flask and all these glass apparatus should be done with water and distilled water. So now let us start the experiment. So first we have to prepare the standard solution. The standard solution that what we are going to use is ferrous ammonium sulfate. So what I am going to do is a known quantity of FAS I will transfer to the flask. So using a funnel you can transfer it to the known quantity of FAS should be transferred to the funnel. To the funnel you can transfer it to the standard flask where you are preparing your standard solution. Tap it. So enough quantity has been tried. So known quantity, the quantity which exactly you have transferred should be known to you. So add some water to see that solids is coming down, and then we have to add half test tube of sulfuric acid. So you have to add half test tube of sulfuric acid. Here you are going to add sulfuric acid to avoid the hydrolysis of FAS. So you are going to add half test tube of sulfuric acid to avoid the hydrolysis of FAS solution. So now you can add some more quantity of water. See that complete solid has been transferred. Then remove it. Then swirl it to dissolve. Don't put the stopper until you make it up to the mark. Swirl it to dissolve always. Okay, so it is completely dissolved. Now you can make it up to the neck using this distilled water. Yeah, up to the neck you can use the wash bottle, the distilled water you have to use. So up to the neck I have transferred, and the remaining quantity I am using the burette. The burette should be washed and rinsed with the distilled water, then only you can use it. So the burette is already washed and rinsed. Now I have to make it up to the mark. See that the lower meniscus should touch the mark. Okay. So you can see the upper meniscus has touched. So what you can do is add it in a dropwise fashion now. Yeah, now you can see the lower meniscus is touching the mark. Now you have to put the stopper and then shake it for the uniform concentration. Three, 4 times. See that it is of thoroughly shaking. So thoroughly shaking can be done by taking the air bubble up and then shaking it. Three, 4 times. Now you can see, okay, the solution is ready. The standard solution is ready for you now. The FAS, standard FAS is ready. So put it aside. Now we will see to prepare the wastewater sample. Wastewater sample, so which we have to determine the chemical oxygen demand. Rinse it with the wastewater. So the wastewater is rinsed. Now keep your conical flask near. Adjust it to the mark, lower meniscus touching the mark. Time, here, fine. Transfer it to the conical flask. See that the 25 ml, whatever you have pipetted out, you are completely transferring to the conical flask. Okay, I have transferred it. So touch the nip 1, 2, 3 times, that's enough. So I have done. I have transferred the wastewater sample. So now I have to add potassium dichromate, a known excess quantity of potassium dichromate I have. So before adding potassium dichromate, I have to see it has been acidic media. So acidic media because potassium dichromate works as an oxidizing agent only in acidic media. So acidic media, along with that adding sulfuric acid, I am adding silver sulfate and mercuric sulfate. So half test tube is good enough to see that the interference is less. So half test tube, add half test tube of it. Okay. So a known quantity of potassium dichromate has to be added to the wastewater sample so that it should oxidize the impurities present inside the wastewater. So now we have stabilized it. We know that 20 cm cube of potassium dichromate is good enough to oxidize the impurities and still something will be remaining. So I can add directly the 20 cm cube. So it is 20 is here. Let's add. Exactly, if I have started from the lower meniscus touching the mark, okay, so I have to stop it to the lower meniscus. If I am starting with the upper meniscus, we have to stop with the upper meniscus only. So 20 cm cube of FAS I have added. Swirl it for 2 to 3 minutes so that it is oxidizing the impurities. Swirl it, be careful while swirling. If it is an industrial waste, or if you take it from somewhere the lake, then you have to heat it for at least half an hour. So since it is in wastewater that what we have prepared, so we can just swirl it for 2 to 3 minutes and then add the indicator. The ferroin indicator we are going to use here. As I said previously, ferroin is 110 phenylanthanylene with a complex of Fe plus 2 ions. So we can add 3-4 drops. 4 drops. So you can see there is no color change because the potassium dichromate color is dominating. So we can't see any color changes. Potassium dichromate color will be there. The end point that what we have to see is from bluish green to reddish brown. The reddish brown is the color of ferroin. Once again we have to get back this ferroin color. So now it is green in color only. We are not able to see the reddish brown. Reddish brown will become bluish green color will come whenever it is near to the end point. So I will start the titration. Okay. To start the titration, your burette should be filled with standard FAS solution. So rinse is compulsory so that you are not diluting your standard FAS solution. And some known quantity from 5 to 10 ml. And then rinse it. So rinsing is always important here so that you are not diluting your standard solutions. So leave it from both the ends. see that there is a air gap, then you can add it. So a phase I have taken here. So now it is above the 0 mark, so you have to fill it a little bit more and see that there is no air gap in the down. So you can just leave it fastly so that there is no air gap, and then adjust it to 0. Since it is a colorless solution, we can see the lower meniscus should be adjusted to 0. Okay, we can see here, it's fine, there is no air gap. We'll start the titration. So now I have kept it for 2 to 3 minutes so that it is completely oxidized the impurities. In the burette, I have taken FAS, fix it so that it is a little bit up, so you can easily hold and remove it out. Start the titration. So end point you have to remember, it should be reddish brown from bluish green. From bluish green to reddish brown you have to get. So you will be able to see the bluish green color whenever the concentration of potassium dichromate is less. So you have to do the titration till all the excess of potassium dichromate has been consumed. So you can see now it is green in color. Potassium dichromate concentration is less. Very near to the end point we are. You can see it's not reddish brown also, but it is not green also. We can see some color changes. It is almost green, a little bit bluish in green now. So now we can see it is very near to the end point. You can continue the titration till it becomes reddish brown. Yeah, so we are able to see reddish brown color you are able to get. So this is the end point. So lastly you will be able to see the bluish green color comes, then you can see the reddish brown color will be remaining. So you should be taking care that after this point whatever the potassium FAS if you add also, it will be no change in the color. So you have to see that from bluish green it should come the reddish brown. After getting the reddish brown, so note down what is the amount of FAS has been run down. So I can see, so to remove it out, make it to the eye level and see now it is almost 12 point, exactly it is now 11.7 ml. So 11.7 ml of FAS has been consumed to oxidize, to react with the remaining potassium dichromate. So this titration is called as back titration. So why it is called as back? So this is because you are finding out how much of potassium dichromate is remaining. You are finding out. That's why it is called as back titration. So one more titration you have to do, that is called as blank titration. In the blank titration, what you have to do is, we should not take the wastewater sample. You should take only distilled water. You have to take 25 ml of distilled water and 20 ml of potassium dichromate, sulfuric acid, and add 20 cm cube of K2Cr2O7, then start the titration. So this will be giving you how much of FAS is required to 20 cm cube of potassium dichromate. So if you subtract blank minus back, that will be giving you how much of potassium dichromate was utilized to oxidize the impurities present inside the wastewater. So you know the titration, the blank titer value, the back titer value. So you have to do at least 3 trials for the back titer value so that you can get a concurrent value, and that concurrent value are you going to use for the calculation, and it is expressed in ppm. So this finishes the experiment to carry out the COD.
At MSR UAS, we spark your imagination unlike any other.